Is to do synthetic division. If you're dividing by x minus 2, what goes in the box? 2. And then our coefficients are 2, 8, negative 5, and positive 5. Make sure if you're missing any powers of x, you include a 0. So the 2 comes down, and it's a series of multiply and add. So 2 times 2 is 4, 8 plus 4 is 12. 2 times 12 is 24, 24 and negative 5 is 19. 2 times 19 is 38, plus 5 is 43. The last number is your remainder, which is all I asked for here because I wanted to know if it's a factor. What does it mean for something to be a factor?
The remainder is 0.
Right, it divides evenly, so the remainder is 0. So my remainder equals 43, which means it's not a factor.
If you're writing that out, like 2x squared plus 12x plus 9
Yes.
plus 43 over
Mm-hmm.
x minus 2.
So that would be how you would write the quotient.
Thank you.
You're welcome. Any questions? $25. All right. So we have our polynomial. So probably a good idea to make sure you kind of review this before your final. We have to find our possible zeros here. So how do you get your possible zeros? What do we have to find? P's and Q's. So the P's are everything that goes into the constant evenly. So everything that goes into 2 would be plus and minus 1, plus and minus 2. Q comes from the leading coefficient, so everything that goes into 4. So plus and minus 1, plus and minus 2, plus or minus 4. Possible zeros are P over Q. Everything has to have the plus and minus, so 1 over 1, 1 over 2, 1 over 4, 2 over 1. 2 over 2 is 1, I already have it. 2 over 4 is 1/2, and I already have it. So those are all of my possible zeros. Does everybody remember how to do that part? Okay, and I would expect you to write all that out, the P's, the Q's, the possible zeros. Then I asked you to find all zeros. So what did we do from here? Yeah. We kind of looked at a graph. A 0 is an x-intercept, so we looked to see if we could pick out an x-intercept, kind of narrow it down. Where does this look like it hits the x-axis? 2. So we'll start with our synthetic division with a 2. So 4 comes down. 4 times 2 is 8. 4 plus 8 is 4. 4 times 2 is 8. Add and we get 1. Okay, it's a remainder of 0 because it's an intercept. So we have 4x squared plus 4x plus 1. What could you do to finish this? Okay. So multiply to 4 and add to 4 would be 2. Oops, I skipped a step, didn't I? X plus 2 and x plus 2. And we started out multiplying by 4, so you have to divide by 4. 2 over 4 reduces to 1/2, so we get 2x plus 1 times 2x plus 1. Okay, so my factored form and my zeros are the two pieces we had to include. The factored form, that's with the x's. So we had 2x plus 1. It showed up twice, so we usually just put a square. What else does this need? Right, 2 is a 0, so it gets an x minus 2. The zeros, you set each of those equal to 0. So if 2x plus 1 equals 0, you get negative 1/2. Because it was squared, that's a multiplicity of 2. And if x minus 2 equals 0, that's a positive 2. So these problems were a little more involved, so that would be a higher point value question. Is everybody okay on how to do that? Alright, so 26 is similar, except I gave you the first 0. If you know a 0, what do you do with that? Synthetic division with the 2i. So 1 comes down. 1 times 2i is 2i. Add and we get negative 4 plus 2i. Okay, now you're multiplying. You're taking 2i times negative 4 plus 2i. So 2i times negative 4 is negative 8i. 2i times 2i is 4i squared, which is negative 4. When you add, those 4's cancel, and we just get negative 8i. So now we do 2i times negative 8i, negative 16i squared, which is positive 16. Now, this seems pretty ugly because we still have i's, but what do you remember about the imaginary zeros?
Can you use the negative?
Yeah, the conjugate also works. So if 2i works, so does negative 2i. And we'll take the answer we just got out. So 1 comes down. 1 times negative 2i is negative 2i. Add and we get negative 4. Negative 4 times negative 2i is a positive 8i. Add those and we get 0. So that's my remainder, my constant x. So we're down to x minus 4. The question was for the remaining zeros. Since positive 2i was already given, we don't have to list it again. So we have a negative 2i, and what makes x minus 4 equal 0? Positive 4. So my remaining zeros are negative 2i and positive 4. Is that one okay? For 27, let's kind of review our asymptote rules a bit. So there's a few things that you will probably need to go back and look at before your final that we haven't covered in a while. How do we find a vertical asymptote?
I'm just gonna
So how do we find a vertical asymptote? Okay. Always x equals a number, and it's what makes the denominator equal 0. All right, horizontal asymptotes. We have two cases. You get a y equals 0 if the top degree is smaller. Doesn't matter how much smaller, as long as the degree on top is smaller, it's an automatic 0. And you get y equals a different number if they have the same degree. And you get that number by dividing leading coefficients. Oblique asymptote is y equals mx plus b, and that happens when the top degree is 1 bigger than the bottom. Yes.
I said, are you gonna write it? Because I didn't refresh it. Let's ask if you're gonna write it. I didn't refresh. They're my notes. It's in my notes. That's not I don't know what I did. So should I would read it. I can remember. If the Y goes right to
Okay. So on A, vertical asymptote, we have to figure out what would make x squared minus 9 equal 0. So that would be positive and negative 3. So we have 2 vertical asymptotes, a positive 3 and a negative 3. Then we have to decide if it has a horizontal or oblique, and that's based off the degree. What's the degree of the top? Bottom. So if the top degree is smaller, it's a horizontal, y equals 0. All right, for B, vertical, what makes the bottom 0? So x equals 2. All right, what's the degree of the top? 2. The bottom? Okay. So what happens when the top degree is 1 bigger? We have an oblique asymptote. We find the oblique asymptote with long division. So the x squared plus 4 goes underneath. You could even put a 0x since we don't have that. And the x minus 2 goes on the outside. Okay, so then we divide. So the first question you do, what's x squared divided by x? X. Then you multiply. So x times x is x squared. X times negative 2 is negative 2x. What do we do at this point? We distribute a negative because we want to subtract that off. So those cancel. So we get a 2x and a 4. And then we're back to repeating. So what's 2x divided by x? 2. And that's actually all we need. So our oblique is y equals x plus 2.
Yeah, can I work over the other thing?
All right, which one did I just say? 28. All right. Let's look at 28. I'm actually going to go through the whole thing on this one. Because there will be something like this on your test. This will be definitely probably a short answer type question. And there's a lot here. So this is worth quite a few points. So the first thing is to factor. On the top, there's nothing we can do. You could write it as x times x if you wanted. The bottom, what would you do? Intercepts. Okay, think about a line for a second. How do you find an x-intercept? It's when your y is 0, right? So if I were to take this and set it equal to 0, the first thing you would do is multiply the denominator over. And 0 times anything is still 0. So you get x equals 0. And that's always going to be the case that your x-intercept is just what makes the top of your fraction 0. A y-intercept is when x is 0. So if I plug in a 0 for all my x's. we get 0 over -6, so 0. Alright, I'm having you find this stuff because I expect it to be plotted exactly on the graph. So your graph here is not just a rough sketch. I want all of those things included. Alright, asymptotes. So vertical asymptote. X equals what makes the bottom 0? So what makes x plus 3 equal 0? And what makes x minus 2 equal 0? Okay, how do we draw asymptotes? Dashed lines. So I expect these exactly on your graph. You go to -3, we have one, and at +2. Alright, and then we have to decide horizontal or oblique. So what's the degree of the top? 2. What's the degree of the bottom? 2. So that's horizontal. If they have the same degree, you divide leading coefficients. So the original one, you had x squared over x squared plus x minus 6. So x squared over x squared, 1 over 1 is just y equals 1. Asymptotes are lines, so I expect equations. Vertical or x equals, everything else is y equals. So we have a horizontal line at 1. And then you can use your calculator to fill in the rest. I would recommend just graphing the original so that if you had any mistakes, you caught them. So we have x squared over, and then put parentheses, the x squared plus x minus 6. And when you're drawing this, it's a function, so it should pass the vertical line test. I don't want to see something like this. That's not what it looks like. It is approaching those asymptotes as time goes on, so you should draw your graph getting closer and closer to them. This is not a V. Everything is curved. It's a polynomial. So, or sorry, rational function. So make sure your graph has some degree of accuracy to it. All right. Is that okay? So 29, 2 of them. The only difference is on part B, it wasn't factored, so you would start by factoring it. What would you do to factor that? Take out x squared, and then they're basically the same problem. So let's do A. So the degree, if I look at this, I have an x minus 4, x minus 2, x plus 2 squared. Your degree is like saying, if we multiply it out, what power of x would we have? So we have 2 x's here, 1 here, and 1 here, so the total degree would be 4. Into behavior. Remember, if it's an even degree, it looks like a parabola. Odd degrees look like a chair. And negative coefficients flip that. If you forget in behavior, how could you check it? Graph it. Okay, you have that calculator, you can use it to your advantage. So it's an x to 4, so it should look like a quadratic. There were no negatives to flip it, so in behavior both ends are pointing up. Alright, zeros and multiplicities. What makes x minus 4 equal 0? 4. What makes x minus 2 equal 0? And x plus 2. Since it was squared, this one has a multiplicity of 2. Then remember, odd multiplicities go through, even multiplicities bounce. Both of these have a multiplicity of 1, so both of those will go through. Because of the multiplicity of 2, this will bounce. Alright, and then we had to get the y-intercept. So if you plug in zeros for all of your x's, we get negative 4 times negative 2 times 2 squared. So 8 times 4 gives us 32. I gave you a grid. You probably had to count by something other than 1 in order to hit 32. I'm going to count by 4. So 4, 8. I hit my y-axis at 32. I hit my x-axis at -2, +2, +4. Both ends should be pointing up. So we start going up. At -2, we said the graph will bounce. Let's go up, hit our y-intercept. Oops. Come back. At +2, we said the graph goes through. At +4, it goes through, and it ends pointing up like we predicted. So I will be looking on your graphs, making sure your end behavior matches. You plotted all your intercepts and zeros. Is that one okay? All right. So then we got into some of the log stuff. So let's look at 34 and 35. Okay, on 32 and 33 you had logs, but you just had one log on each side. What did you do on those problems? Change it to exponential, and the log would go away. Okay, here, let's combine. If two logs are subtracted, how do you put them together? So this would be the log of x plus 7 over 3. Then we had a property that says if you have a log on each side, you can drop it. So that's supposed to be so if I multiply over my 3, so we get x plus 7 equals 21x plus 3. Subtract the x over, subtract my 3 over, divide by 20, and x is 1/5. Make sure on these log problems you are checking your answer. What has to be true on the log problems? Yeah, this argument has to be positive, so make sure that when you plug it back in, those numbers are positive. All right. Number 35. So this one is similar. We have multiple logs. If you have logs being added, what do? Multiply. So that gives me x squared plus 4x plus 3. And then we have a log on each side. Oops. So what do? We can drop the log. So x squared plus 4x plus 3 equals 3. Subtract the 3 over. Okay. What do we do now? Copy x. So you get x equals 0 and -4. Check. 0 plus 3 is positive, 0 plus 1 is positive, so 0 works. -4 plus 3 is negative though, so -4 is not a solution, and 0 is our only option. Problem 36. So we had a few exponential problems earlier, problems 30 and 31. How did you solve those? Common base. Is that an option here? So what do? So we prefer either the natural log or common log because we have those buttons easily accessible on our calculator. Then if we think properties of logs, what happens to the exponent? So you're trying to get x by itself so you can divide by everything else. So we'll divide by the 3 and the log 4. So x is log 6 over 3 log 4. You put that in your calculator. Make sure you watch your parentheses. We know anytime you push a log button, it opens parentheses, so you need to close it. You also need a second set around the entire denominator. And that's where I got my 0.4308. And 37. How do we graph a log? Sorry, say that again.
1, 0, negative 1 to the log.
Yes. If you change this to exponential, you have 4 to the y equals x. And we know when we graph exponentials, we've used negative 1, 0, and 1 for the exponents. So that's the y here. So 4 to the negative 1 is 1/4. 4 to the 0 is 1. 4 to the first is 4. So then we plot those points. So we have 1/4, negative 1, 1, 0, 4, 1. It's just going to get closer and closer to the axis. That's actually your asymptote here. So it looks like that. So our domain is from 0 to infinity. Range is negative infinity to positive infinity. Is this okay? Okay. I know we have.
I'm so curious what that means. I just did not do it right.
I already erased the whole thing.
Why would you erase the whole thing?
No,
I don't even understand how it was.
I did
erased
the
it.
substitution, didn't work. I did the substitution, didn't work.
It's
I
just
did
sometimes when you just
did
like,
not.
I don't even think I
You just
finished
need to
it.
start
No, the
Yeah,
time I
same
started,
thing.
I didn't
Yeah.
finish it. I started.
Yeah.
What
What would you do to solve this one?
Multiply the first one by, multiply the log by 2.
Okay.
I don't think that's right.
So
No, wait. This-
you could take the second one, the first one times the negative 2 if you want to cancel x. If you want to cancel
Oh.
y, take the second one.
What number? 39.
Oh, we skipped it, yeah.
So we get 20x squared plus 2y squared equals 100. So this gives us 25x squared equals 125. So 125 divided by 25 is 5. To get rid of a square, you square root plus and minus. So x is positive or negative radical 5. So that's the first half of our solution. How do we get our y? Okay. Does it matter which one? So if I just go with the second one. What is radical 5 squared?
5,
Times 10?
18.
So y squared equals 0. So y is 0. What's going to happen if you plug in a negative radical 5? So those are my solutions. Is that okay?
Yeah.
Sorry, did I?
Sorry, I was.
No, it's okay. I get excited sometimes and just can't wait to start a new problem.
You can see that. You can see that today, the ELA line.
All right. Let's look at this one. It's a little bit different because only the first equation has all of our variables. So, what do you want to get rid of? Y or Z? Z. Okay. So, if I wanted to get rid of my Z, let's take these two equations because they're the only two that have a Z. What would I have to do? This one times, so we get negative 15x plus 3y plus 3z equals 0. And this one we have a 2x minus 3z equals 2. So when I put those together, I get here. Now if we look, we haven't used this equation yet, but it has an x and a y, and this one has an x and a y. So I want to put those two together. What do you want to get rid of? Doesn't matter, but I heard x first. So if I do x, what would I have to take this one times? So that would give me so we have this together, those are common. So y is 67 over 16. Now we just have to start plugging that back in and get the other variables. So if I went to this one, I have x plus y, which was 67 over 16, equals 5. Subtract that over, so 80 minus 60, so we get 13 over 16. So now we have x and y. We need z. We can use any of these. I'll use the bottom one. So 2x minus 3z equals 2. Divide by, that's positive. Divide by -3 and we get z to be -1/8. So now we have x, y, z.